Hello and welcome to this video. Here we'll be learning about the factor theorem and how to use it to simplify algebraic polynomials and algebraic expressions. So let's start with a very simple example where we have a quadratic here which is factorizable. Okay, we've been told to factorize and solve when this quadratic is equal to 0. So factorizing it, we'll have factors of x minus 4, x minus 5. That means that one of the solutions is 4 and the other solution is 5. Now, if we had to plot it on the graph, what would it look like? Look, so it would cross the x-axis at 4 and 5. Now, a less reliable method of factorizing is by substituting. Now, if we had guessed that x is 4 and substituted 4 in for x, we would end up with 0. Now, here we are substituting 1 and we're guessing 1. Now we're not getting a 0. So this 1 is not this equality is not true. Okay, I should change that to a not equal to. So x minus 1 is not a factor. Okay, this is just saying, let's see what's happening. We're just experimenting. If we substitute 2 into the equation, we will get a method. So what does that tell us? So this other expression here, this is not the same as the one above. This is saying that one of the factors, because we substitute 2 there, is x minus 2. Alright, because 2 was the solution there that worked out to give us the 0 that we needed. So we change its sign, we write x minus 2, and then we can say, alright, if one of the factors is x minus 2, it might be easier to guess the other factor, because 2 times what will give me negative 16, 2 plus 2 times 8, so then you just write x plus 8, and you check the answer. If you add the 8x and minus 2x, you get a plus 6x, so it works out. So yes, this method here is guess and check. I know it's guess and check, but it works out. Sometimes it will help you. So we were looking at the graph for this first factorization there. So it has the zeros at 5 and 4. We call these roots or zeros. Sometimes you hear math teachers say, what are the zeros of this polynomial? They mean basically when y will be 0. What x values will make the y value 0. So that's why the remainder, okay, so I must point out to you the remainder of dividing by x power x minus 5. If we performed algebraic division here and we said let's divide x squared minus 9x plus 20 by one of these factors, alright, so when we substitute 5 in here, then that means we dividing by x minus 5. So when you perform this division, you end up with x minus 4 up there, and bam, 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 you end up with remainder of 0. That remainder of 0 is this over here. Okay, so here, for example, we had a remainder of minus 9. If you perform algebraic division on x squared plus 6x minus 16, let's write it, x squared plus 6x minus 16. If we divide it by x minus 1, we used x equal to 1, didn't we? So if I write here x minus 1, let's perform this division. We're going to multiply x by x minus 1. So we get x squared, and that's a 6 there, sorry. So we'll have a minus x here. I'm going to put a bracket and around. I'm going to show you what the remainder is, so you believe me. I pointed out to minus 9 here. So when I subtracting minus x, I'm going to have a 7x here as a remainder. I bring that 16 down here. So now I need to put the plus 7 here, because plus 7 times x, dividing 7x by x. So there, times minus 1 minus 7, right? This is a plus, right? We're going to put the minus sign outside the bracket. What's negative 16 plus 7? Look, minus times a minus makes that so. It's going to be a negative, right? Remainder is negative 9. All right, and remainder, and when we evaluated the expression with x equals to 1, we got that answer. All right, yes, all right, so we had 1 square plus 6 minus 16, and we got the remainder without performing the algebraic division. Wasn't that fancy? Wasn't that really amazing? If you do divide it by, if we did divide by x minus 2, we would get remainder of 0, because the x equal to negative 2, sorry, x equals to 2 is the solution, and x minus 2 was one of the factors, right? So there is a connection with the remainder, and when you perform substitution, we knew the remainder even before we divided it, just by substitution. All right, so there you go. Let's look at the next example. It should clarify things. So in this question, let's just generalize what we learned. We said if we substitute the value of p in some polynomial, and we get a 0 as the answer, then x minus p is a factor of fx. All right, make a note of that. Then if on the other hand, if x minus p is a factor of f of x, then when you substitute the value of positive p into the expression or polynomial, you will get a 0. That's either one way or the other is true. So if f of 3 equals to 0, x minus 3 is a factor. If f of minus 1 is 0, then x plus 1 is a factor. Notice the change of sign inside the brackets. Okay? So if x minus 5 is a factor, then substituting 5 into that expression will give us 0, and so on and so forth. Okay? So in this question, we've been asked to show that x minus 2 is a factor by, and pay attention, there may be one of these ways that the question asks you. Not always, the question doesn't always ask you to do algebraic division. If the question asks you to use factor theorem, you'll do something else. But let's answer part A first. You're just going to say x cubed divided by x. I need to put x square up there, and perform multiplication, find the remainder, 3x squared. So 3x squared divided by x gives me 3x, so I'm going to put a 3x up there, multiply it up, and find the remainder. 2x divided by x give me 2, so I'm just going to put a plus 2 up there and multiply it up, and I find the remainder 0. So I've answered part A. Algebraic division gives me 0, therefore x minus 2 is a factor. All right. Now, if they want me to use factor theorem, that means substitution, right? X equals to what will give you 0, all right? X equals to 2, right? Because just say x minus 2 is equal to 0, right? This is like mixed. This is one of the so the root is x equals to 2. So you perform this substitution. You need to write out, simple as it might be. You just need to show this calculation. 2 cubed is 8. 2 squared is 4. 8 plus 4 is 12. 12 minus 8 minus 4 gives you 0. Okay, so that's the difference between algebraic division and factor theorem. Make a note of what the question is asking you to do, and do what the question is asking you to do in the exam. So in this example, Let's see, the question is not the same. This is a different question. So we've been asked to fully factorize 2x cubed plus x squared minus 18x minus 9. Hence, draw the graph, sketch the graph for it. So it involves using your knowledge of chapter 4 in this question as well to sketch the cubic graph. First of all, we're gonna have to find one of these factors. So yes, this is going to be a guess and check work. All right, we haven't been given any clue of what any of those factors are, and it's a cubic. So okay, what you can do is just take very small numbers around 0. Okay, let's test it with x equals to 1. We're gonna substitute 1 for x, and we get the remainder is minus 24. So that's no good for us. X minus 1 is not a factor. All right. So then we test x equals to 2. We substitute 2 into that expression. Yes, you do it. It'll take you about 30 seconds to put that in your calculator. And you see the remainder is negative 25. Therefore, x minus 2 is not a factor. What about 3? Alright, let's test it with 3. 1. The remainder is 0. Okay, so therefore x minus 3 is a factor. Simple as that. Now you know one of those factors. The question doesn't tell you use factor theorem or whatnot. All you know is now you can divide, you can perform algebraic division, polynomial division with 2x cubed divided by x minus 3 and the rest. So we're going to do that now because we need to know the other roots of the equation when we're plotting the graph. Remember, we need to know all the factors inside brackets, right? So I'm performing algebraic division here. You say 2x cubed divided by x gives 2x squared. You multiply it up and you get a remainder of 7x squared. 7x squared divided by x gives you 7x. So you put that up there. And then you say multiply up 7x by those x minus 3 and find the remainder. Take care of the negative sign there. Be careful. Always use brackets. Brackets here. All right. So then we dividing 3x by x, so that gives us a plus 3 up there, and you multiply up and find the remainder is 0. Bam. So now you know that this cubic can be written as such. Okay. Now it's not hard to factorize the next bit here. You take 2 times 3 is a 6, so you can write it as x squared plus 7x is a 6, therefore 6 and 1 go in the bracket. You write x plus 6, x plus 1, and you don't forget here we multiplied by 2, so we need to divide by 2 this. Alright, my divide by 2, yeah, divide by 2. So one of the factors is an x plus 3. This 2 don't the 1 don't divide by 2, so you put it in front of x, you write it like so. So these are the bracket forms. So these are the factors of that cubic polynomial. You have x equals to 3, x equals to minus 3, and x equals to negative half. Alright? So now remember how to plot the graph here. You look at the coefficient of the cubic here is a positive 2. Therefore, when we have x and y axis, we put the ends of the graph here. It has to come where x is positive and y is positive. That's what that positive coefficient is telling us. When x is negative, y will be negative. That's in this quadrant down here. And you look for 3 minus 3 here. That you just say if that's a 3, maybe I should put it somewhere else because I do need to squeeze minus half there as well. So I'm gonna just rub this off and use the PowerPoint here. So those are the factors we found. So to divide it proportionally, you put minus 3 further out here. Should have thought through, and minus a half there and 3 there. And you say end of the graph will come down here. none of these roots are repeated, therefore the line will have to cross here, have to come up, make a U-turn, cross this point, make a U-turn, bam, goes down there. Now it doesn't matter how far up you take it, this U-turn you can make it as long as it's a smooth curve. That should be fine. Make sure you don't have sharp ends in your graph, because then they won't give you full marks. It needs to be a smooth. It's a polynomial. Alright, so it has to be smooth. You do need to find this coordinate. How do we do that? Remember? What's the value of x on the y-axis? X is 0. So when I put 0 here, here, and here, I'll be multiplying -3 by 1 and 3. So when x equals to 0, y will be -9. And it makes sense for it to be a negative value because it's under the x-axis. Alright, so they've actually drawn it down there. So I better get rid of this. Okay, so we've sketched the graph, we've answered part B as well. Okay, and yeah, that's just saying that factor 3 is just checking. You don't have to do this, but the 3, when you substitute it into that polynomial, will give you 0. So that's in this question, in the next example here, given that x plus 1 is a factor of this quartic equation, we need to find the value of a. Now you say, all right, that means I have a factor here. I know that if I substitute a -1 into this equation, I should get 0. So that's the quickest way to do it. You just substitute a -1, and because it's a factor, it should give you 0. So this constant, you figure it out with this numerical method. You evaluate this expression, and you end up with a 4 minus 3 plus a. So that's a 1 plus a equals to 0. A must be -1. Alright? Simple as that. Okay, so let's see. In this next few examples, I made these questions are not in the A-level book, but it's good to understand them. So I'll have a go at these questions. Pause the video, have a go at read the problem first, have a go at the first one at least, and then watch the rest of the video. All right. So we've been told two facts about this polynomial. We don't know any of these coefficients here. I could have put the a in front of x cubed there as well to figure it out, but doesn't matter. So it is divisible by x minus 2. That means remainder will be 0. Okay, when it says is divisible, that's what it means. And then it says, but leaves a remainder of -35 when divided by x plus 3. Find the value of b and c. Assuming a is 1 there in front of x cubed, so just to make your life a little easier. So what we do is substitute the 2 into that polynomial, and we write it equal to 0. Why this equal to 0? Because is coming from the fact that it says is divisible 1. Alright, they don't have to explicitly tell us if the remainder is 0, but this is the remainder when is divided by x minus 2. So where that 4 came from, 4 was just 2 square, okay? A value of x when it's 2 to 4, when x is cubed, you get 8, and when x is 2, you just have a 2 here. So this is one equation here. And then the other equations, when we substitute x equals what? X equals -3. When we substitute the -3 there, we're going to get another polynomial. Now we're just tidying things up. In this equation, the 2 and 8 is a 10 on the left. So we took that 10 to the right and wrote it -10 there. All right. So we put that equation aside. We're substituting -3. The same polynomial will give us this expression here. Now, why did I write -35? Because they told me the remainder was. This is the remainder. Remember when I showed you that very first example? Go back and watch it, and you'll see why the remainder is minus. We're putting remainder here, and Negative 3 square cubed is negative 27. Negative 3 square is positive 9. And that's the negative 3 there. And that's the c. Now we can tidy things up a little bit. We got these two constants here. They give us minus 30. We can we can add this 30 to the right side, and we'll get minus 5 here. So rewriting that, we'll just have this expression here. 9b plus c is minus 5. Maybe after this. I'm just showing you the working out here. But so we've got these two equations. Equation 1 is coming from over here, and that's equation 1. This is equation 2. Okay, this is equation 2. This is equation 1. So now you just solve it simultaneously. It's not hard. There's two equations, two unknowns, so subtracting one from the other. Say 9b minus 4b is 5c minus c is 0, and minus 5 minus a minus 10 is positive 5, b is at 1, and therefore c is, you substitute 1 back into either equation, you get c is minus 50. Alright, so I hope you found that helpful. Pause the video again, have a go at question 2 and 3. Once you've done it, you can play the video and I'll show you the answer. But I'm not going to show you the whole working out here. So have a go at it. There you go. I'm going to press the play button and it just show you the final answer. You should get is A is 2, B is 1. And for the next question, you should get A is minus 1. Alright, so there was just one coefficient missing in question 3. Alright, so good luck practicing. I'll see you in the next video.